Calculator in degree mode. Calc in degree mode. Okay, so in a prior lesson, forget which one, but in chapter 4 somewhere, we talked about finding missing sides, or missing sides giving an angle, which is just like this warm-up. So if we look, we have a sonar on a salvage boat. Okay, sure. And here is an object. Appears to be a, shark with a lot of teeth. Here's our boat. Downward angle of 50 degrees. Looks like if we're using our 50-degree angle, we have opposite and hypotenuse, which means we should use the sine function. So sine of 50 equals d over 510. Then if we're solving, we can multiply both sides by 510. So 510 sine 50 is equal to d, which is our depth. If you put that in your calculator, you should get 390.68, and our units are meters. Again, that should be review. Pause for a second, more than a second, however long it takes you to do this problem. Pause the video and do this one, and come on back and I'll review it with you. Okay, assuming you pause this, we draw our picture. There's our vertical wall. Here's our ladder. Angle of 75 degrees with the ground, which is right there. The ladder is 12, because again, our ladder is not going to be, I think sometimes people make the mistake of putting the ladder here, but a ladder would fall over if you just set it there. We have to lean it. There's our right angle. We want to know how far from the wall we should put it, so there's our x. So using our 75 degrees, we have adjacent and hypotenuse, so that's cosine. Cosine of 75 will be x over 12. Multiply both sides by 12. 12 cosine of 75 will be x. So x is 3.11. Units are feet. That single apostrophe is feet. If it was 2, it would be inches. So now we're going to talk about finding angles. So when you're finding sides, you use sine, cosine, and tangent. When we're finding angles, we use the inverse function. So basically the opposite. First, we'll just write it, and as always, I'll explain it as we go. So to find theta, we could do the inverse sine. Sine -1 is just inverse. Weird, but true. Opposite over hypotenuse. And when we did inverse functions, f -1 of x was the inverse of x, so it should be somewhat familiar. We could find theta by doing inverse cosine, cosine -1, adjacent over hypotenuse. Or we could use inverse tangent of opposite over adjacent. Again, calculator should be in degree mode or you'll get totally weird answers. So if we have a triangle ABC, talking right triangle, angle C is a right angle. Here's our right angle, that'll be C. A and B can go wherever you want. I'm going to put A here, B here. C is a right angle, got that. AB is 5. BC is 3. We want to find angle A. So let's call angle A theta. First of all, some of you might be thinking, let's find the third side using Pythagorean theorem. And you totally can, but you don't need to. So we'll set up our equation the same way as we did when we were finding a side, only now instead of sine, cosine, or tangent of an angle, we just have theta. So given theta, we have opposite and hypotenuse, so that'll be sine. So our equation is sine of theta equals 3 over 5. And essentially what we're doing, we want theta by itself, and to cancel out sine, we do inverse sine. So we will do inverse sine to both sides, and they will cancel. It's not really multiplying by anything, it's just performing an operation, kind of like to undo multiplication, you do division, and vice versa. So these will cancel. So we have theta equals inverse sine of 3 over 5. And that's just either pressing that button. Usually it's on the scientific calculator, it's second and then the sine button. Otherwise, this shows up under the trig button, I believe, in your graphing calculator. Otherwise, Google's a great way to figure out where that stuff all is on your particular calculator. And if you put that into your calculator, you'll get 36.87 degrees. Here's another. Triangle ABC, C is the right angle. So there's C, A, and B I'm going to put here again, but it doesn't matter. You could switch them. If AC is 3, oops, sorry guys, just like in class again, right? AC is 3, BC is 3. Again, could you find the hypotenuse? Sure, but I'm not going to because we don't need to. We want to find angle A. So that's theta again. So now we have opposite and adjacent, so we will use tangent. So tangent of our theta, which is angle A, if you wanted to say tangent of A, you could, but equals 3 over 3. So we do inverse tangent of both sides. So theta is inverse tangent of 3 over 3. Feel free to write that as 1 if you want to, which is 45 degrees. For this next example, we're just told to finish solving the triangle, which is find all their side lengths and angles. So solving a triangle is simply finding all the missing sides and angles. So we look, here's what we know. 3, 3, C, A, B. Theta is 45 degrees. Well, finding the measure of angle B should be easy enough. The sum of the angles in a triangle is, and here you would say 180, and I would say, yes, that's true. So we can do 180 minus 90 minus 45, which is 45. So this other angle is also 45 degrees, which should make some degree of sense because if this is 45, side opposite is 3. This is also 45, side opposite should be the same. So that's part of it. And then to find AB, we'll do, just make that an arrow. So we call that x. Do Pythagorean theorem, 3 squared plus 3 squared equals x squared. 9 plus 9, 18 is equal to x squared. Square root both sides. So AB is the square root of 18. If you want to split it this way, 9 times 2 is 18. So this is the same as 3 square root of 2. Not a huge deal if you didn't see that right away. Calculator, 4.24. So we can put a 4.24 there. And then we have all the parts of our triangle. We have both sides here, both legs. We have the hypotenuse, angle, angle, angle. So that is a solved triangle. Okay, I would say, how are you guys doing? Are you still with me? But I'm hoping you are, but since I'm alone in my, office / extra room, this is all we have. All right, angle of depression, angle of elevation. Here's your eye, I guess. It looks kind of weird. I would draw an eye, but it would just look creepy. So angle of elevation is the angle between the horizontal and your line of sight. So if you look straight out, that's horizontal. And elevation is when you're looking up. I would put my arm straight out in front of me here and say that's horizontal. If you're looking above your arm going straight out, that's angle of elevation. So this is looking up. Angle of depression is the same as above, but looking down. So looking out, straight out, say your arm, I'm holding my arm out in front of me, but then looking down. Just getting stuck. So for example, if we have a building, here's our building, just 30 feet tall. We're always doing right triangles. Let's make one. It's a terrible triangle, but we'll just go with it. Here's our right angle because we're assuming the building is straight up. It's not leaning. That would be unfortunate. Here's the sun. Make it a happy sun, right? Yeah, suns are happy. Looking down, cast a 5-foot shadow. We want to know the sun's angle of, this should not be elevation. This should be depression because the sun is looking down. I don't know what the sun's looking up at. That would be weird. So essentially the angle, we have to go from the horizontal, which is here. So we actually want this angle because the sun would be looking straight out, but it's not. It's looking down from the horizontal. If it was ours, that would be different, or the grounds, but we're talking about the sun. So I'm going to move these over. If this is 30, this is 30. This is 5. This is 5. So we have opposite and adjacent, which is tangent. So tangent of theta equals 30 over 5. Cancel out tangent with inverse tangent. So theta inverse tangent of 30 over 5, which is equal to 80.54 degrees. Here's another. This one's angle of elevation. Someone's hiking straight up a mountain trail. And straight up is kind of confusing, but a mountain trail is not literally straight up because you're not like climbing. So we're saying like, this is your mountain trail. And you're hiking 7 miles and you gain 2 miles of elevation. Here's our right angle because we're talking elevation from right angle. And again, everything should have a right triangle or we can't even solve the problem. So we want the angle of elevation of the mountain trail, which is here. Essentially, if you were laying on the ground, you were looking straight out, you'd be going this way. But we're looking up from there. So that's our angle of elevation. So we have opposite, and we have hypotenuse. So sine of theta, 2 over 7. Inverse sine both sides. Sounds kind of weird, but that'll cancel out. Oops, sorry guys. We'll get theta equals inverse sine 2 over 7, which is 16.6 degrees. Pause, try this problem. Come on back and I'll show you. Okay, I'm assuming you paused and did the problem. 20-foot ladder. Ladders are pretty common. Height of 15. Again, ladders are always leaning. They're not going to go straight up. We're assuming the wall has a right angle with the ground or it's a, pretty badly built building. Angle of inclination is the same as elevation. So like if you're laying on the ground looking up. This is a sine again. Sine of theta is 15 over 20. Inverse sine, theta, inverse sine of 15 over 20, which is 48.59 degrees. Really want to say any questions, but I will say any questions. Please ask a friend, text a friend, phone a friend, email me, post it on the discussion board. I want to know what you don't know and I want to know how you're doing. This one, do on your own. It looks like an H. It says on your own, I promise. Your answer should be 86.18 degrees. If you don't get that and you're not sure why, the posted completed notes have the work. All right, thanks guys.